Compound interest. You might have come across statements like 1 year interest for FD, that is fixed deposit, in the bank at the rate 9% per annum, or a saving account with interest at 5% per annum. Interest is the extra money paid by institution like banks or post office on money deposited with them. If we deposit certain amount in a bank for 2 years, 3 years, then for that bank gives us extra amount, extra money. That one is called as interest. Now there are two types of interest. One is simple interest and other is compound interest. In simple interest, every year we get the same money, extra money. And in compound interest, we get interest on interest. Let us try to understand with this chart. Let us consider we deposit rupees 100 at the rate of 10%. So at the end of the year, we get rupees 10 interest and our principal 100, so we get 110 rupees. Under simple interest, next year your principal is rupees 100 again, and you get interest rupees 10, and next year you have this 110 rupees plus 10, and you have now 120 rupees. But in case of compound interest, the interest amount is or extra money is same at the end of first year for both simple and compound interest. But what happens here, this interest is added into principal, and compare these two numbers. For simple year, your second year principal is 100, but here it is 110. So you get interest on that rupees 10 which was interest, and now the interest for second year is 11, and you get rupees 121 at the end of second year. With simple interest, we will get again the rupees 10, and at the end of 3 years we have rupees 130. But with with compound interest, the interest is paid on interest, and we get here 3 rupees and 10 paise extra. Now this difference is negligible. You will say why to use a compound interest just for 3 years, but this is for 100 rupees only. Your rate of interest may be greater, your deposited amount can be greater, and at that time this difference will be considerable. Now we are going to deduce formula for compound interest. We know that formula for simple interest is SI is equal to principal into rate of interest into number of years divided by 100. But for compound interest, we deduce that formula to A is equal to P into 1 plus R upon 100 raised to N. Let us explain this formula. What is this A? A stands for amount. Amount is principal plus interest. P is principal, R is rate of interest, and N is number of years. So by using this formula, we get the amount after N number of years at the rate of R, and the principal is P. Now if we want to calculate compound interest, then we can subtract principal from the amount value. What are the applications of compound interest formula? There are some situations where we could use the formula for calculation of amount in CI. Here are a few. Increase in population or decrease also. The growth of bacteria if the rate of growth is known. The value of an item if its price increase or decrease in intermediate years. Now whenever there is growth, then we write this formula as, for the case of growth, we write this formula as amount is equal to principal into 1 plus r upon 100 raised to n. But if there is a depreciation means the value decreases, then we use amount formula. Amount is equal to principal into 1 minus r upon 100 raised to n. This is for growth, and this is for depreciation. Growth means increase in number, and depreciation is a decrease in number. Now the value of any vehicle or any machine decreases after number of years. That is called as depreciation. Okay, so now let us try to solve exercise 7.3. The population of a place increased to 54,000 in 2003 at the rate of 5% per annum. This is the increased population in 2003, and we have to find out population in 2001, before 2 years. So our formula is population in 2003, that is increased population, can be obtained by population in 2001 into 1 plus, this is r, that is rate of interest, upon 100 raised to number of years. Now we have this value, we have this as 54,000, and we want to find out this population. Let us consider or denote it by p. This is 1 plus, we can reduce this fraction, 5 upon 100. These numbers are divisible by 5, so we can reduce it as 1 upon 20 raised to 2. Now this is addition of fractions, and the denominators are not same. We have to make them same. So let us multiply this by 20, and its numerator will also get multiplied by 20. So this fraction now becomes, it is 20 upon 20 plus 1 upon 20. Now denominators are equal, so we can add the numerators, can add these numerators. This is 20 upon 20 plus 1 upon 20. This can be written as 21 upon 20, or let us write one more step, and that is 20 plus 1 upon 20 square. So we have 54,000 is equal to p into 20 plus 1 is 21 upon 20 square. So this is again 21 upon 20. Now to get value of this p, we have to transpose these numbers. They will perform opposite operations. 20 and 20 are dividing on this side. Opposite of division is multiplication, so they will be there in numerator, and these are in numerator. After transposition, we can write them in denominator. Now this 54 is multiple of 3, and 21 is also multiple of 3. So let us divide these numbers by 3. We obtain here 7, and here 18,000. Now these are again multiple of 3. So let us divide this by 3 to get 7, and this is now 6,000. So P, that is population in 2001, can be obtained by 6,000 into 20 into 20 is 400 upon 49. Complete this calculation and you will get the population in 2001. Now population the next part of the question is what would be its population in 2005. So we have population in 2003. By using this we can find out population in 2005 as population in 2003, which is 54,000 into, is this 1 plus 1 upon 20, that can be written as 54,000 into 20 plus 1 upon 20 square. So this is 54,000. This square is for 2 years into 21 upon 20 into 21 upon 20. Please complete this calculation and get the answer of second part. In a laboratory, the count of bacteria in a certain experiment was increasing at the rate of 2.5 per hour. Find the bacteria at the end of 2 hours if count was initially 5 lakh and 6,000. So here we write first count or initial count, and this is the rate of increase per hour. This is increase, so here we are going to add this R upon 100. So bacteria, number of bacteria at the end of 2 hours is, initial count is 5 lakh 6,000 into 1 plus. Now before we simplify this, let us try to remove this decimal point. How it can be removed? There is 1 digit after decimal point. So to remove this, I multiply by 10 in both. So 2.5 into 10 is 25, and here this is 1000. Now 25 can divide 1000. Let us reduce this fraction. 25 ones are 25, 25 4s are 100, and this 0. So this reduces to 1 upon 40. So I will write this as 25 upon 1000. That is equal to 1 plus 1 upon 40 square, that is 40 plus 1 upon 40 bracket square. That is equal to 41 upon 40 into 41 upon 40. So complete this calculation to get number of bacteria at the end of 2 hours. A scooter was bought at rupees 42,000. Its value depreciated at the rate of 8% per annum. Find its value after 1 year. In above two problems there was increase. This is increase in number of bacteria. Here it is increase in population, that is number of people. But here we have depreciation. So value of scooter will decrease, and it will decrease by 8%. And you have asked to find out value after 1 year. So here number of year is 1. So what is our initial cost? Initial cost is 42,000. Let us reduce this 8 upon 100. These are divisible by 4. So we get 2 upon 25. Okay. So 4 2s are and 4 25s are. So here I will write this 1 minus 2 upon 25. No need to write this 1 as that power is 1. As we write nothing, we consider that power is 1. Now the denominator is 25. Multiply this fraction by 25 in both numerator and denominator. So this becomes 25 upon 25 minus 2 upon 25. Observe here the value of fraction is same. Here we have 1 and 25 upon 25 is also 1. Now this one is 42,000 into 25 minus 2 is 23 divided by 25, and by completing this calculation you will get a value of scooter after 1